Hey everyone, and welcome. So, you've got the Java basics down, but you're ready to really level up your skills, right? Well, you're in the right place. We're about to dive into some advanced concepts that are going to give you way more power and precision in your code. So, the real question is, are you ready to power up? Because we're about to unlock 3 major upgrades that will totally change how you write and think about Java. Let's see what's in store. All right, here's the game plan. First, we're going to get you to Masterclass Control. Then we'll get into designing flexible, reusable blueprints. And finally, we'll check out some slick, modern features that'll make your code super clean and elegant. Let's dive in. Okay, our first power-up is all about being precise. These concepts give you that fine-tuned, granular control over how your classes and objects behave, how they use memory, and exactly how they come into existence. The big difference here really comes down to what's shared versus what's personal. Think of a static variable, like a public bulletin board in an office. Everyone in the company sees the exact same information. An instance variable, that's like a sticky note on your personal monitor. It belongs only to you, or in this case, to each specific object. So where does all this stuff actually live? Well, Java has 2 main places. You've got the heap, which is this big shared space where all your objects and arrays hang out. But then you have the stack, which is much more organized. Each thread gets its own private stack, and every time you call a method, a new frame gets pushed onto it. When the method is done, poof, that frame gets popped right off. It's a really efficient system. You know that new keyword? Every single time you use it, you're calling a constructor. This is the official starting point for any object. It's where you set up its initial state. And what's cool is you can have multiple constructors with different parameters. That's called overloading, and it lets you build your objects in a bunch of different ways. Think of the final keyword as your do not touch sign. If you put it on a variable, it becomes a constant. Its value is locked in. Put it on a method, and you're telling other classes, you can't change how this works. And if you put final on an entire class, that's the end of the line. No one can inherit from it. It's a really powerful way to enforce your design. All right, on to our second power-up, creating flexible blueprints. This is where we start thinking bigger than just single classes. We're talking about designing systems that are easy to reuse and expand upon. The classic Java question. Here's the deal. An abstract class is like a partial blueprint. It can provide some implemented methods, but leave others for subclasses to figure out. An interface, though, is a pure contract. It says what a class must be able to do, but provides 0 details on how. This is also Java's secret weapon for something like multiple inheritance. A class can only extend one parent, but it can implement as many interfaces as it wants. Upcasting is super simple and, thankfully, completely safe. You're basically treating a very specific object, like a dog, as its more general type, like an animal. Since a dog is an animal, this always works. Java doesn't even make you think about it. It just happens. You're moving up the family tree. Now, downcasting is the opposite. And this is where you gotta be careful. You're making a promise to the compiler saying, hey, trust me, I know this animal reference is actually pointing to a dog. If you're right, great. But if you're wrong, if that animal was a cat, your program will crash with a nasty class cast exception. Pro tip, always, and I mean always, check with instance of before you try to downcast. And for our final power-up, let's get into the fun stuff. These are features that make your Java code cleaner, easier to read, and just more expressive. It's all about writing less code to do more work. So before we can talk about the magic of Lambdas, we need to meet their foundation, the functional interface. And it's super simple. Any interface that has exactly one abstract method counts. That's it. Think of it as a contract for a single piece of functionality. And wow, just look at this slide. This is the perfect example of why Lambdas are amazing. On the left is the old way, all that clunky, verbose code just to do one simple thing. Now look at the right. The Lambda expression strips away all of that ceremony and leaves you with just the part that actually matters. It's so clean. And this quote just hits the nail on the head. Lambdas aren't just for looking cool, they have a huge practical impact on your code, especially when you're working with lists, handling button clicks, or dealing with multiple threads. They let you focus on the what you want to do, not the how. Okay, this is a quality of life feature that I absolutely love. Before text blocks came along, trying to write multi-line strings for things like JSON or HTML was a total nightmare of plus signs and escape characters. Now, you just use the triple quotes, paste your text, and it just works. It's a game changer for readability. And finally, we have enums. Instead of just using flimsy strings or numbers for things that have a fixed set of values like days of the week, enums let you create a special, type-safe class. This means the compiler can catch your typos, which makes your code way more robust, especially when you use them in switch statements.
And there you have it. We've just unlocked 3 powerful sets of tools. You've learned how to take total control of your classes, how to design flexible systems with abstraction, and how to write clean, modern code using things like Lambdas. So, as you head back to your code, what's it going to be? Which of these power-ups are you most excited to master first? Is it going to be the precise control from final and static, the architectural freedom of interfaces, or maybe the sleek elegance of Lambdas? The choice is yours. Thanks for watching.